Hey guys, hope today finds you well if you're a distance learner. And we're going to talk a little bit today about why we are going to be using the metric system in science and then how to apply it as well. So those are going to be some things that we're going to look at. So why are we going to use the metric? First of all, at least in the scientific realm, there's only 3 countries that do not use the metric system primarily, and those would include the United States, which is us, go us, a country called Liberia, and a country called Myanmar. Other than that, there's 190 some other countries in the world. Maybe there's more, maybe there's less, give or take, depending upon the week. But really, we're kind of standing alone. These guys aren't necessarily world players in terms of science is concerned. So we're trying to get you guys at least acclimated to the idea of using metric because that's going to be primarily what we use in this class. So what are some of the advantages of metric? If we were to compare length, if you look in the U.S. system, okay, we've got an inch, there's 12 inches in a foot, there's 36 inches in a yard, there's 72 inches in a fathom, 198 inches in what's called a rod, 7,920 in a furlong, there's 63,360 in a mile. So you see that we've got all these kind of random numbers that relate each other to length. But if we look at the metric system, I could have a meter, and then I've got 1,000 meters is a kilometer, 1,000,000 meters is a megameter, 1/100th of a meter is a centimeter. It's all based upon 10. Okay, it's all based upon the number 10. So it's readily convertible between these units. Okay, now when I shift these, it's kind of easy. If I go from kiloliter to deciliter to liter to deciliter, if I go from a big number to a small number, all I have to do is multiply that number by 10 or basically move the decimal point. If I go from a smaller unit to a larger unit, so let's say I'm going from a milliliter to a kiloliter, I'm dividing by 10 with each step. So it gets relatively easy to do this because if you're multiplying by 10 or dividing by 10, all you're really doing is moving the decimal point. And we're going to talk about that a little bit. So if we were to look at volume, notice we've got all these different ways of measuring volume in the United States, especially if you are a chef or a cook. You might use cups, pints, quarts, ounces, teaspoons, tablespoons, but look at the relationship. There's no rhyme or reason to it, yet the metric system is pretty consistent and dependable. If I'm looking at units of mass, in the United States, we have the dram. We've got 16 drams in an ounce. We've got 16 ounces in a pound. We've got 2,000 pounds in a ton. So again, doesn't seem to be much of a rhyme or reason with metric. To go from a milligram to a gram, I'm going to divide by 1,000. To go from a gram to a kilogram, I'm going to divide by 1,000. To go from a kilogram to a gram, I multiply by 1,000. To go from a gram to a milligram, I multiply by 1,000. Again, fairly straightforward. Okay? And the nice thing is that metric, and the whole basis for the metric system is that it's all based upon one of the most common substances in our everyday lives is based upon water. If I have 1 gram of water, I have 1 milliliter of water of volume. And that means that 1 milliliter is the equivalent of having 1 centimeter by 1 centimeter by 1 centimeter of water. So these 3 are all the same amount. Notice, I can convert between mass, between volume, and between units of length, all within one fell swoop here. Okay? So water is the premise behind our whole metric system. There's nothing that compares in English. Okay, this is something that's universal that we can count on. So you can see there's lots of reasons why the metric system is more utilitarian in terms of how we can use it in the world of science. Okay, now you're going to watch a second video here that is going to help you pick up some tricks to solving in metric. And the basic thing is I either go up or down a stair-step ladder. Okay, if I'm going up this stair-step ladder, I'm going to be dividing by 10. If I'm going down this stair-step ladder, I'm multiplying by 10. Okay, this happens to be the top part of the ladder, but there's a second video here that's going to kind of walk you through how to use this ladder method to solve metric conversion problems. I want you to watch that, pause it, see where you need some help, and then you're going to apply it on an assignment that you will finish for the day. So that is what you are going to have for a game plan. Once you're done with this video, click on this YouTube video which illustrates how to solve those problems, and then I want you to solve metric conversion problems as well as review some of those significant figures measurements that we were working on in class. Okay? Other than that, I will talk to you later. Have a great day.